go. Start recording. All right, here we go, and then I'll share a screen. Welcome, everybody. Tonight is the 20th of April. It is Robot Builders Night, DPRG. We get together each week and meet and share our projects and questions amongst like-minded persons. There's a couple of housekeeping things I want to show tonight. First of all, for those of you that are still shopping and lost it, we did have on April meeting, Jesse from SparkFun Ambassador gave the presentation, and he has these SparkFun discount codes. So you can grab a screenshot of those for 15% off for the next week, roughly, or 10% off for the rest of the year. Then tomorrow night, I did a cross post for us, but Harold is actually lined up with Hackster DFW, a guy who's pretty active on Twitch, and he's going to give a presentation and discussion, interactive, I guess, about designing circuit cards. And I know in the last week or two, in this Tuesday night session, we've had questions about how do you size traces and wires and stuff. So if you've been on the edge maybe of thinking about how to design a circuit card or just wonder what's involved, that should be an interesting thing tomorrow night. And then on the 8th of May, we have this lined up for sure. Miro and Max from Germany and Switzerland will present on their 3D printed Mars rover model. So that'll be pretty cool. And
they've promised to defend Ross.
You know, they have Docker images and GitHub and well documented stuff. So I'm really looking forward to it. I hope you all are too. Yep. Aside from the cross-continent thing, that's always fun. And then in June meeting, we have David Anderson, how to do navigation without making a map. And then in July, I just want to put this on the table, and if there's any comments right away, that'd be great. But otherwise, just chew on it. We don't have any presenter for the 10th of July meeting. But it turns out that Seattle Robotics Society has announced their Robothon on the same day. So I was wondering if in lieu of a DPRG proper meeting, did we want to just gather up our own little robot projects and offer to present and just be a part of their Robothon? Food for thought. Yeah. I'll bring it up again. And then all this working up towards the end of August on the 21st will be our outdoor competition, which I know we have some competitors, and that should be fun. I didn't have any other housekeeping. Does anybody have anything else they'd like to, Doug?
Yeah, just want to, people, I think it was last week we said we'd have the remote location guidelines out by the 15th. They are in review right now. They have been completed, but they're just people are looking at it and making suggestions. That's Carl primarily, but it's also you, John. You should be looking at.
Yeah, I glanced at it. I sent a note.
John's given a thumbs up, and I haven't had a chance to read it yet. But basically, in contrast to past years. At David Anderson's suggestion, it looks like we'll have probably some 2 levels of competition in there. One is for human planned, where when you walk the course, you can drop as many waypoints as you want. And the other is robot planned, when you basically get the 3 waypoints, and whatever the obstacles are, the robot has to find its way through all of them. So.
Yeah. I mean, I had read over that email of David's and thought the same thing, that those are very different contests.
Well, they're going to be. You got to realize it's being layered on top of the original contest, so it's an additional challenge. And so, like I say, it's in review right now to make sure everything is cool, and then we'll go ahead and publish it. It does mean that there is a change in the rules, and then there's the change in the guidelines. Okay, but they're different topics. Right. The rules are incorporating David's suggestion. The guidelines are new, and this hopefully will allow people from remote locations to join in on this. Now, there is an action that I would love somebody else to take because I don't have the bandwidth for it. You have to assume that in a remote location, these people do not have a Wi-Fi available at their course. So somebody needs to check out if they can get on Google Meet with a phone without Wi-Fi. I don't know if that's possible.
I can confirm it. I mean, I've done it.
Okay, it's doable then.
I mean, you still need a good cellular, but
Yeah,
do it.
well, we can assume they have probably reasonable cellular. I know that when we were at the park, we didn't have any Wi-Fi at all. Like we didn't have any power except for John's generator, and we didn't have any restrooms, which was kind of a pain in the butt. But
there's only one tree.
yeah, and so now with this new location, it'll be a lot better than that. And but other people in remote conditions probably have similar places to what we ran into in the park. So if we just make sure that they can actually, download a Google Meet app or go into Chrome or whatever they need to do and join the meeting. That's all. We'll have it in our location. We'll probably have it on a screen, a big screen.
Okay.
But just to clarify, Doug, so if we were to delineate those two different sort of sub-contests or challenges, one of them is where the challenge is for the human to be able to move through the course and somehow track onto a recording device the location, and then be able to have the robot follow that course.
No, you can never take the robot on the course.
Right.
So you can't just track it around. And okay, so that means you're going to have to depend on some sort of navigation system. Most people do GPS. GPS generally has an accuracy of 10 yards or 30 meters. So if you're trying to do a complex course going around obstacles using GPS as your guide with no obstacle avoidance, good luck. You're probably not going to make it. You're not going to get a perfect score. And I proved this to myself several years ago, where I whacked the front of my robot really good with a nice tree. But so that's the reason why people put obstacle avoidance on their robots. But I view David's challenge even bigger than that. Otherwise, what David is really saying is the guy gives you 3 waypoints, and we're saying you don't even go on the course. You've got 3 waypoints, and you got to remember we have a target point, and the cone has to be somewhere in 10 yards of that target cone. Now, there's 2 reasons for that. One, because we give you a GPS, we can't absolutely guarantee it's right. All right, but we can be in 10 yards. And the second thing is, it's sort of like in golf. They move the pins around every day so that the actual hole that you put the ball in is actually in different locations. So this one, the way we're viewing this is, you get three coordinates, go have a cup of coffee, when it's your turn, turn on your robot, it goes and does it. And now, we're not going to change the definition of perfect score, or at least that's the way it is right now. Otherwise, if you do it by waypoints and you get a perfect score, you'll get the title perfect score. All right. But if you get it in the robot class, which we recognize as a larger challenge, you also get the title. Let's see, what is it? I think it's called the 3 waypoint challenge. that gets added to it. So you'd have a perfect score with 3-point challenge. Okay, so prizes, it's a, how you approach it doesn't matter. Prizes are a common pool. So you don't get a special prize for running the challenge course. But, if you're good, and, for example, David who came up with the suggestion is good, there's a good chance he'll win anyway, unless somebody else takes him down. Scott's pretty competitive. Now, we're going to have a bunch of hopefully new people who have never ran this successfully. Otherwise, like I run it, the best I've done is 3 points. Okay, that's the best I've done. And now I got it by going 10 feet of each cone. That was it. I never stopped. I never hit the cone. All right, but that was my level of expertise at the time. So this time I'm hoping to at least get 6 points, So anyway, but I'm hoping other people will be there too. And also, I did look at the the European rover project. They have a open source robot there that uses parallax robots, parallax servos as motors and steering servos. And it's really, really pretty good. So we'll see how it goes. Those are the proposals. And like I say, right now, Carl has put a deadline for the 26th on it.
Quick update.
Okay.
This Google Meet on my phone is through cellular only, so it didn't have any trouble.
Cool. I feel better now because we're telling these guys to join us. And, I know that if they're out there in some field in Colorado with no Wi-Fi, I was concerned that they would be able to join us on the meeting, because the real thing is for this is that everybody from all the locations, to be kibitzing and, slapping down and doing other, having fun. That's what we want to do. And if they can do that, can you video? Can you do, since you have it set up, can you go into video mode?
You see me showing my robot on the floor?
This is no Wi-Fi, right?
No Wi-Fi. This is on cellular.
Okay,
Turn the
so
Wi-Fi off.
that's cool, because that means they should be able to stream their runs.
Yeah, you see it turning around. It's responsive. It's a little slow.
That's okay, because
Wait for your picture to come in because it was coming in over cellular. But once it updated, it's pretty responsive.
well, knowing that, we might in the guidelines right now, we tell them that if they can stream it, to go ahead and stream it. And but it sounds like we can make that a little stronger statement, since they should be able to stream it. If they can stream it, we're going to allow them to send us videos and put them on YouTube and get them back to us, be considered. So anyway, so I'm hoping, even people like in New Zealand might try give it a shot if they have time.
Do we know anybody in New Zealand?
I don't know anybody in New Zealand, but I've been there. Beautiful place, beautiful. Ted, you mentioned you were going. Where do you live, Ted? I'm not familiar.
Right outside of Denver in Aurora, Colorado.
Okay, so you'd definitely be a remote site, unless you wanted to come on down.
Yeah,
we'll feed
I'm
you
still
lunch.
thinking about driving down, but it's a long drive.
Yeah, if you come on down, like I say, we'll do our best. We might be able to find a room for you.
Oh, that'd be cool.
Okay, just let you know.
Yeah,
And
thanks.
I haven't seen. Has anybody seen Paul? Oh, Pat. Sorry, Pat.
He's
You
right.
know,
I'm
if you're into this interests you at all, you'll be able to do it, from your own locale.
Yeah,
without,
I'm a little bit interested in seeing how this is going to work and what we got to do.
okay, like I say, everything's in review. There'll probably be some minor changes from what we got right now, but should see it no later than next Tuesday. Right? Is
Okay,
that
great.
right? Yeah, because it's supposed to be finished by the 26th. So 27th. You'll see it on the web. It's the day before the next meeting.
Yep.
You too, Chris.
So
Get out of that.
is the Dave Anderson plus version, you know, basically the same course, but
It's the same course.
obstacles in the straight line?
It's the same course. The rules aren't changed there. What's been changed is we've added 2 categories. There's a category which allows you to walk the course in the beginning
Oh, okay.
and to set up additional waypoints. And then there's a section, then there's the robot one where you're not allowed to walk the course, but you can have the waypoints verified on your unit, your GPS unit, if you want. They shouldn't be different, but if you feel let's say you run round one, and your robot went way over there when it should have gone way over here, and you think that we have a bad waypoint. After you check your own waypoints that you entered into your program, you're also allowed to ask us to recheck, so that you're not going after a bad target. That's all I have.
Do I have any audio?
Yes.
That's all I have.
Okay. Well, Carl, you ready for it?
Cool. Yeah. So
Show you.
let's dig in,
Okay.
John. Why don't we go John, Murray, Doug, and then I will, and then whoever else.
Okay. So I was surfing the web and ran across this. So let's see, I need to click here to move it. So yeah. So basically, seemingly they have a robot with a video monitor and that.
Telepresence.
So telepresent is what
Yeah.
they're doing. And they call it Peanut. So it's a 4-foot one that seemingly does that. So if y'all want to see a robot in a restaurant, I said in Florida, there's one out there.
Cool.
There is actually a robot restaurant in Tokyo, but I think it's basically robot themed.
Right. Well, this
Pretty crazy.
seemingly, they have basically about 3, and it looks like, yeah, they have one that actually brings the meal out, and the other one's more of the greeter type thing.
I think in Tokyo they're actually like Japanese women in cosplay outfits.
Oh, and I want to say they spent like $10,000 for each one. Somewhere in the article I saw something about 30,000.
Yeah, I was watching Naomi Wu. She went to one of those robot things in China, in Shenzhen, and literally they place the order. The robot shows up here with a tray of food. You take the tray of food off of it. You swipe the card, do all that kind of stuff, and it goes away again. I don't think she ever saw a person at all. Just everything got robotized to her and went away. Had a robot make her a hamburger too. And the whole assembly line hamburger thing coming out. That's that was pretty cool.
Nice.
Now I want to take a field trip.
No.
Well, it
We
does
should do it in
look
a weight
cute.
team.
At least the
Next meeting in
greeter
Florida.
does.
So, related to that robot actually being used in the restaurant and businesses. So what they found out, so in Japan, there was a hotel that they hired a numerous number of robots. And one of the things that they tried was 3 different types of receptionists when you walk into the hotel. One of them is dressed like human. So Japanese version of like Sophia was what she looked like, Uncanny Valley, scary looking. And then next one is in the Dino costume. and next one is the miniature robot looking thing, now robot. So after like 6 months of operating, significant usage from the Dino robot only, and almost no one approached the human-looking thing, and just a very small number approached the robot-looking robot. So for the human and robot interaction perspective, what it looks like really does matter.
Huh. So
Good to know.
what's the name of, do you have an image of the one that people, like the three that they compared and the one that won?
I don't have any image. This is something that is really widely seen in Japan. So I heard one of the Japanese presenter in their robot club that so the hotel shut down because of no customer. But the scientists who pursued it actually did conclude that the trust level of what the robotics can do is largely depends on the outside. So it's only skin deep, but it does matter to human.
Huh. That's pretty fascinating. Okay. Hey, so Murray, what you got this week?
Well, not any moving robots, but I've been making progress on a number of things. First of all, put your hands up if you're aware of a Python website called PyPy. That's PYPI. Anybody? Okay. Well, for those who are not, it's when you go onto the command line and type like pip3, which is the Python package installer, pip3 install and the name of a library, it goes off to PyPy and then downloads the library. It's like apt on Linux or something like that. Basically, it's an installer site where you can put libraries and you can put your own libraries up there. And so what I'm currently doing is taking my 50 or 60 or whatever number of files in my robot operating system and subsetting that as a core, maybe just the logger and my subsumption architecture and my async message bus, and basically making like about 5 or 6 or 10 files and calling that, and I'm relabeling my project KROS because ROS is taken. So it's K series robots of my robots. So it's called cross-core. And so what I'm doing is learning, which is quite tricky, how to create my own Python package, put it on GitHub, point the PyPy site at it, and then anyone in the world could then just type pip3 install cross core, and it would load my core onto their machine. And then that means for me that the, I don't know, dozen SD cards that I've got, when I create a new SD card, I can just type in a few commands and it'll actually, rather than cloning my repository from GitHub and getting all these files that I don't need, I could just install the libraries as libraries on my robot. So that's kind of what I'm doing Python wise. So that's one. And then number two is I've been still struggling after, I don't know, more than a year, trying to find some way in Python to have a master-slave controller. So I'd have the Raspberry Pi as a master and some kind of processor as a slave. And yes, you can do that in C++ and Arduino using Fermata and stuff like that. But doing it in Python is tricky. And I had bought some of the unexpected maker chips like the Tiny Pico, which runs MicroPython. But it turns out that of all the ESP32 boards that are out there, it has the ability to do I2C slave hasn't been ported to that particular board. It's been ported to the Pi board and a couple others, but not that one. So I still don't have a board that can actually run MicroPython as an I2C slave yet, unless I'm willing to port it myself. So that's kind of on hold. Beyond that, I got a huge shipment. Well, huge for me. It was $120 in shipping charges for about $140 in parts. If that says anything about the cost of shipping to New Zealand through the US. If you go through Canada or the UK, you can use, UK or Canadian Post, which is cheap. But this was through one of the, I think not you, I can't remember which one of the vendors it was, but it was a courier. But I've now got very cool stuff. So this is the beginning of a rocker arm with a servo block that has the steering mechanism and the motors, and I've got, you know, $120, $140 worth of parts here. It's like the most expensive Lego kit you've ever seen. But this is all the Servo City stuff, and it's pretty impressive. I mean, I've got like dual bearing mounts to mount this up onto to create the rocker bogie arm, and so it's lots of fun. What I think I've mentioned before is I'm trying to do 1/6 of a it's probably not going to be rocker bogie. It'll be triple rocker, which is what the ESA, the European robot, uses, which is easier to create because you don't have to have the differential in the center. The NASA robots have 2 rockers with a arm or a shaft going through the center of the robot with gears or whatever, so that as the one rocker turns one way, the other one actually alters in the other direction. But the guys that we've been chatting with from ExoMars and that ExoPi project have been saying that the ExoMars project uses the triple rocker design, which is what I'm probably going to do here. But if this doesn't prove to be so expensive, if I can find an alternate shipping mechanism and I can come up with a design that I'm happy with, and these motors, the servo that I've chosen and the motor that I've chosen, which is a 22 mil motor, if all this is suitable and I don't need to change it too many times, I'll come up with a sort of a pseudo final design hardware wise, and then consider buying the rest of the pieces and start going towards building this, which would be my first truly outdoor robot. I mean, my KR-01 is a 4-wheel robot that can go on my deck and go outdoors, but it only has, where have I got the wheels? It's got, you know, wheels like that, which are probably okay for some outdoor locations, but they certainly can't go over a curb. And the wheels I've got for this one, I'm probably going to have to manufacture my own wheels, because these are like standard wheels, big rubber wheels that I bought from Servo City. But one of the things I found in almost all of the hobbyist Mars rovers is they usually stick the motor off on the side of the wheel like that, which means the motor's going to hit rocks and things. It's a really imperfect solution. Some of the most beautiful robots, like the Beatty robots, is like a dad and 2 girls have built all these robots. All of their Mars rovers have the motor hanging off the side like that. And so if I'm going to do this, I'm going to try to do it right, which means I'm going to have to somehow, I think, manufacture my own wheels so that I can enclose the motor inside the wheels the way the real Mars rovers have done. So I've got, for example, this plate from Servo City, which mounts onto the motor. And then what I would do is probably get some PVC pipe or stainless steel tubing or something like that and create my own wheels. And so I'm going to try prototyping a wheel as part of this sort of project. If I can come up with a wheel I like, and if I can come up with a steering mechanism that's got a servo that's strong enough and all that, I'll continue. But right now, this is sort of an experiment, an expensive experiment, but it's an experiment. And apart from that, I think that's it from New Zealand. So,
Rory,
yes.
Have you actually looked at, you know, the people that are going to give the talk next week or next month? Their particular rover, they use, well, in their case, they're using an actual standard size servo as the motor. Vex makes a motor called, I think it's the number 32 or something like that. And it's a rectangular motor too that would fit in a similar. And what they did is they made a yoke, a little yokey thing, and then they run the motor out through the U part. So this part of the yoke protects the motor, which sits in here like this. Okay, so I mean I thought that was an interesting idea because of what you'd said before. So you might look at that and see if there's anything there you might be interested in.
Well, I mean, there's kind of a couple things there. First of all, like this particular servo, I mean, Servo City sells probably 24 servos, and they come in the standard size like this, and they've also got the larger ones. So part of this experiment is this is what they call a servo block, which is their patented, you know, connector with ball bearing shaft and all that. And so if this size motor, I should say servo, doesn't work, I can go to the next size up, or I can even go to a more powerful servo motor. There was a guy who I can't identify on his YouTube page, but he started building a Mars rover about 5 or 6 years ago, kind of finished it, and then he stopped posting, and he doesn't have a name or anything. There's no contact information, but in his Mars rover, he'd actually ended up putting a large gear on the bottom of this to like a 5-to-1. But there's so much complexity in all those extra things. And if you've got a servo, frankly, just upping the size of the servo, getting a really powerful servo is probably a lot easier than adding external gears. But in terms of that yoke you're talking about, that is actually like one of the trickier parts, which is to have like the wheel mounted on to the motor and then have that kind of yoke over the top, because you want the servo to connect up basically at the point of the rotation of the wheel and not like way over here, which causes a pivot. So that yoke I've kind of got, let's see if I can find it. I've got pieces from Servo City to try to build a yoke like that, but I played around with them, and the problem, of course, is that they don't have exactly the size of piece I need, because frankly, the yoke has to extend all the way over to where the center of the wheel is. And so the guy that just cut my hair, his brother has a CNC machine. So I've got a possible CNC solution, or I was trying to find sources of aluminum extrusions in New Zealand, but most of them have like a minimum order of 200 kilograms. So I can't just get a small piece of aluminum. Yeah, well, these are meant to be OEM suppliers. I can't find a retail supplier of like larger aluminum beams. And I only need like, what, 4 pieces, maybe an inch wide, like on a channel beam. So I'm not sure what I'm going to do. I could possibly manufacture it, or I could build it out of, bar aluminum, which is less than great, or even weld it or something like that. But that kind of channel yoke where the one arm is slightly longer than the other, one is the one that the motor mounts on, and it's actually big enough to actually have the wheel fit around. That's the trickiest part of this right now in terms of finding a single piece of aluminum that could do that work.
You might look at openbuilds.com. Openbuild.com.
Will do.
They have aluminum extrusions, and they have some that are actually shaped like a U.
Okay. Oh yeah, I found
it. I think it's going to be openbuildspartstore.com.
It's openbuilds.com.
It is?
Yep, I just found it.
Because I remember running into that before, but yeah.
It's plural. It's openbuilds.com. Yeah. So yeah, I'll take a look. Thank you, Doug. Because I guess what like this guy that cuts my hair said is that if his brother has got enough time and I would pay him to do it, I would effectively come up with a design on some kind of a standard, hopefully open source package, and give him this on a file, as a file, and he would then go ahead and build it. I guess I'm not sure how that would work out in terms of paying him and all that, but it sort of reminds me of go ahead.
Do you have a 3D printer by any chance, or access to one? Oh, okay.
No, and I don't plan to buy one.
I said if you had one, printing something like that out of nylon is plenty strong.
Oh, really? Well, this robot could weigh like 5 kilograms, and I want it to be strong enough.
It could still be plenty. It might look a little bulky. You might have to add a little bulk to it, but
or gussets or something like that. Yeah.
Well, and it's a good way to prototype your parts just to see if they fit and work.
Yeah,
that's true.
Go Pat's method and use wood.
That's true.
I can't use wood. It wouldn't survive on Mars.
Well, it grows on trees.
Just for prototyping.
You could maybe there's places that'll 3D print for a fee and deliver, right? So if you just had the model file, you save yourself the trouble of finding somebody with a shop and just have it show up at your doorstep.
Yeah.
Well, I'm more in mind of actually getting a CNC print machine that I'd rather take it out of like solid aluminum and have lightning holes and things like that in it, so that it's really light and strong rather than plastic. I mean, I've seen some of there's tons of Mars rovers projects online, and a lot of them solve this with plastic, but I'd kind of like to see if I can do it in aluminum if possible. I mean, I've got like these are actually really light. It's unfortunate that Servo City doesn't have them just a little bit longer, but in any case, I'm kind of trying to build them. My Mars rover, if I end up building this, I keep putting that if on there, would be slightly smaller than a lot of them out there. And I've kind of mentioned, I've got a wiki page beginning on this and everything. And I'm at this point trying to design it as 3 separate kind of subcomponents. There'd be a front component, a middle component, and a back component. And each one of those would have their own controller, because there's going to be 3 sets of motor encoders and the sensors. And I mean, there's a ton of stuff coming in. And I kind of want to be able to have a sub-process. This is that whole sub-process thing, master-slave controller, where I can just say to a sub-processor, turn the steering this way, set the speed of the motors this way. And I don't have to have all of that at the master controller level. I'd like to be able to push all this stuff off to sub-processors, but I still don't have that even working. Unfortunately, like I said, I'm on the what's it called, the Unexpected Maker Discord chat board, and trying to get anybody to even pipe up and say like, oh, I've done an I2C slave on an ESP32. And actually, what's interesting, David will find this interesting, is I did find, wow, very nice, David. I did find that of all of the I2C slave implementations out there, there is one for an STM processor like David's got. So if I moved over to using the same boards as David uses, I could get an I2C slave. So,
well, in theory, it should go down all the way down to the blue pill or the black pill. I mean,
but you need it in Python, right? Mary, you want it in Python, yeah.
Yeah,
okay.
MicroPython.
I ran into the exact same issue. Because I'm trying to turn my QtPy, which out of the box runs Python,
right,
into, smarts for my, 8-channel line sensor. And I talked about it last time, right? And I realized the exact same thing. CircuitPython running on that QtPy board, which is a Cortex M0, doesn't support I2C slave.
Right.
Okay. The documentation says it should, but I guess it depends on which board you're using, and this board doesn't have that built in. So I had the same problem, and I had to decide, screw it. I'm just gonna program that QtPy in the Arduino framework. Done. Because the hardware, obviously, all these hardware, they all support I2C slave. It's just Python didn't support it, and you ran into that issue also.
Yeah, in fact, what I did was I actually downloaded, since all this is all open source, I downloaded the whole I2C library that comes with MicroPython. And in the directories, you can see all the implementations for all the different boards. And that's how I know the STM32 or whatever, the one that David uses, was available, and not the ESP32. And so in theory, if I could figure out how they did it, and there is actually a port of MicroPython from a guy named Lobo or something like that, who's actually ported it, but it's not in the MicroPython main library. It can be done. I only have so much bandwidth as well. And I figure that I have to implement my own I2C on MicroPython seems a bit over the top right now. So I'm kind of waiting. I think someone will do it, but it's not going to be like next month, I don't think. But it's kind of sad. You'd think this stuff would be all just available already, but it's hard to imagine that I'm the innovator here. There must have been people before me trying to do this.
Yeah, but it's more common. The more common use case with these boards is that you talk to some I2C slave, right?
Yeah.
Whether it's a memory device of some sort or a B&O 55, right? So you are usually 99 out of 100 times, right? These boards are the master,
right? And
something else is the slave. But you and me seem to be doing it the other way around, and so yeah.
Yeah.
Well, don't they have like I2C expanders chips?
There's all sorts of
options. I want to say that I ran into those on LCD displays. And what I was wondering is, can you trick it? Can you essentially talk to one of these expander boards, and the expander board is a slave, and then, but on the other side, you're saying you're using a master to talk to this, you're porting to the expander board, and so it doesn't, you looks like you're a master.
Well, the problem is that if you think about the master-slave relationship on I2C, is that a slave device like a B&O 55 or whatever is basically being polled, and needs to
Right.
react like a slave. And they absolutely, if they're on that particular bus location, they have to respond every time they're pulled. That's the rule. I mean, they are a slave.
Mhm.
And a master device doesn't do that. And when you create your I2C, like if you, let's say in Python, say, give me an I2C on this particular, on port 74 or whatever, or bus address 74, if you tell it it's a master in the code, it comes up as a master. If you tell it it's a slave, it comes up as a slave. And the behaviors are, of course, different. And so you can't fool a device. Like a master never responds to a query. It only comes up and
No, but it
pull.
can
Where
pull.
Doug is going is use one of those, use another chip that's a hardware I2C slave, interface that with your board and with Python that doesn't do that slave function, right? So now you have bolted on an I2C slave. The thing with some of these expanders that you're talking about, Doug, is like some of them just do GPIO, like the ones to drive the old style LCD. So you can write to it, right? You can write 8 bits to it. That's all you can do. If you're trying to implement like a smart sensor node or kind of a smart co-processor node of some sort, you got more bi-directional communication going on. Sometimes you wanna send it something, right? Like a command, or you wanna send it something. Like in my case, I need to send it something that gets translated into PWM, and then you need to read something back. In my case, that's like the A to D converter outputs, right? And so you don't get that with these simple expanders that you're talking about.
Okay. I was just wondering if there might be a way around it, but it sounds like
As
no.
far as I know, no, because and Chris kind of outlined that kind of scenario, which in my case, for example, would be the front or the back of the robot, or let's say my integrated front sensor, where I'm actually going to send a command or a series of commands, and I have to write a library around that says, turn the steering on the left motor this way and the steering on the right motor this way, and set the velocity of the motors to this, and they have their own PID controllers, and all that's got to happen locally on that assembly.
Okay.
But all the control back and forth has to be pretty high speed, and it's got to be at kind of the next level up. You don't want to be bit banging across that interface. You want to be sending commands. Otherwise, there's no.
So in chat, Adafruit puts up this I2C multiplexer that might do what you need to do or help you, or maybe not. I don't know. I put it.
No,
I don't know if it helps you or
it
not.
doesn't change anything.
Okay.
All it does is allow you to have different buses. On the Raspberry Pi, we got 2 buses, one that's like the standard bus, and you can use a second one. And the multiplexer allows you to have more than one device at the same address by altering the bus that it's on.
Yeah.
With MicroPython, can't you? I mean, you can extend it by creating a new class, right?
Sure.
Or probably in this case, it would just be adding on to the I2C function of the machine class.
Mm-hmm.
And I believe is that done in Python or is that done in C?
Both. And it effectively, like I said, there's a guy out there who has done the port for a different board. And I think if I wanted to take on another project, it would be doable. I mean, I'm not a great Python programmer, but I've come a little way along. And I've seen the guys port for a different board, and I've seen stuff done on this board. But in order to actually do the slave functionality at the low end, I'd have to do that in C. And then once I've done that, then I can write the MicroPython implementation to interact with that. But it's not a trivial project. I mean, it can be done, and I think I could do it.
Yeah, but I thought you said you already had the slave. You already had slave software in C because it was an STM32.
For other boards, though, yeah, it'd be for STM32.
If it's SMT32, doesn't matter. They're all gonna, the same code should fit it, as long as it has an I2C bus. And that's their big selling point. You can have an M0, you can have an M4, you can have a C7 or whatever. I mean, you can take your code and upgrade or downgrade the processor to whatever your project's cost point is. Okay, now obviously you can't have floating point that you have on a 4 and you take it down to an M0, but there's a subcore of functionality that gets ported all the way up. So if you started at an M0, there's no reason you couldn't run that same code on an M4.
Well,
Yeah,
like
they're,
I
they're
said,
HAL. They at the bottom level they use HAL. They're so hardware abstract level.
Yeah, yeah.
And that, like he says, it's common across all of their boards.
well, in looking at the actual code for the MicroPython I2C implementation, like I said, I've downloaded and looked at the library, the library itself, the code of it. There are subdirectories for all these different things for each different board at the implementation level. And there is actually a directory for ESP32, but there's no implementation for the slave yet.
Oh,
but as you said, I've got the code, and in theory, I could almost, if you're, I mean, I'm not contesting that you're right or wrong. I'm only saying that no one has bothered to do it. Yeah, but if that's
I'm
the case,
playing with you, Murray. Poke, poke, poke.
well, yeah, believe me, I've got enough projects, believe me. But if I could basically take the directory from, let's say, the STM32 and just copy the files over and maybe make some name changes, maybe it would work. I don't know.
Well, but the thing is, you're using ESP32, right? Not STM32. So I think.
Yeah. Oh, you're using ESP. Oh, I'm sorry.
Yeah.
Okay, I'm sorry. I thought I heard you say you were STM.
I've got these little. This is the ESP32, the Feather S2, and then the ones that are actually on my robot right now are the tiny. Here's one. It's a tiny Pico. And so what I'm doing is, this is my little hookup into the Raspberry Pi, the I2C connection, and this is the power connection. And trying, but yeah, so far. I mean, maybe this is something I can tackle, in my spare time. So, but thanks for the advice.
Or don't use Python for that, right? Just use something else that supports what you need to do.
I was trying so hard not to say that.
Yeah, I know this, of course,
because the thing, it's a relatively dumb code processing node, slave node, whatever you want to call it, right? So there isn't going to be a ton of code there, right? And so on that kind of node, maybe you shouldn't care if it's running Python or 50 lines of C code.
Well, let me explain that, since I'm not disagreeing with what you guys are saying, but let me explain why I'm going with MicroPython. Is whether I use the little Feather S2 or this tiny Pico, which is a 2-core, 240 megahertz processor, by the way. This is a powerful little board. The benefit of running MicroPython is that I can, in theory, port my KROS or Cross or whatever, my robot operating system, my PID controller, my logger, all the stuff that I've got all this software investment in, I can port that over and run it on here. So if one of these is at the front of my Mars rover and one's at the rear, I could have the Raspberry Pi in Python interacting with code on this thing, running the same code on that board. And that's kind of the goal. Yes, I could do it in C++, but if I can run the same code on one of these little boards and interact with it over I2C, that's kind of a nice, I don't know what you call that. It's a nice, clean, single language implementation across maybe 4 processors or 3 processors. So that's kind of the goal here. And yeah, I could do it in Fermata, and that's bit banging, but I really want to run almost a whole little sub robot on these sub processors, not just, because they're going to be running PID controllers, sensors, servos, because I'll have a 2 servo controllers for the front and 2 servo controllers for the back. There's lots of stuff that'll be running on these little boards. And the idea is to sub-process that off to the 2 front and back rear, and the Raspberry Pi in the middle has the control over the whole robot and the sensors. That's kind of the idea.
And you're sure that you're not adding unnecessary complexity, right?
Chris. Mark. Go easy, Chris.
Oh
no.
If you think about it, okay, I do have an answer for that, and that is no, because I'm not adding unnecessary complexity, because if I can run the same code on all 3 processors, then as I make changes to the code and I plug that in and then download that code onto these little processors, I don't have to maintain 2 code bases. I've got 1 code base. So from the software side of things, it'll be easier.
Murray, I'm totally with you. As long as it's not Fortran or Tiny Basic or something like that. This or PHP. I mean, as soon as you start talking about running your robot with PHP, then we're going to worry. But this is a good.
Aren't we going to do it with COBOL?
I love the idea of doing it in Fortran, actually.
It wouldn't be the first nor the last.
And I'd actually go to a surplus shop and buy one of those card readers and actually program the thing with Hollerith cards.
That would be impressive.
That would be impressive.
Yeah,
When you walk up to your robot and you get a stack of cards to make it move, that would
I got
be
a
really
cardboard
impressive.
box. My program is in a cardboard box that you don't want to drop on the floor.
Don't trip.
I used to program the HT11s in assembler.
So that when you drop the cards, you can get them back in order.
What I used to do is actually take a felt marker and write diagonal stripes across them, across the tops. That way you don't have to hand number them.
Exactly. Yeah.
All right. This is a good principle.
On them.
I guess we're all we're showing our age, eh, Dave?
Yep. Limping along.
Yeah, my first program was in Fortran on Hollerith cards.
Yeah, I did quite a few in that form.
And
I also did PL1.
Oh yeah, yeah. I remember carrying my card box up to the station at the university and handing it to the person, and they would go and load it into the thing, and you'd hour later come back and see what happened.
Oh, you know what?
Oh, how do they relate to this group?
Ben did that.
Yeah, pretty much. Pretty much at JCL, we always had that game. We submit our stuff, and it's like, okay, name that ab-end. Which one are we going to get this time?
Do kids take typing classes nowadays? I remember like it being a mandatory class when I was in school, but do kids take typing class?
They call it keyboarding.
Oh.
And they do, yeah. I don't think they actually bother to teach them to write, like with a pencil.
Yeah,
I think it's just a skill they're born with.
Was typing in high school. That was good.
Kids nowadays, I think they all type. Don't have to go to school to learn it.
I thought they were born that way, actually.
Yeah, most 3 or 4 year olds can type on mom or dad's computer. And
But they're not full typing. They're 2-finger typing, aren't they?
Does it matter?
That's
oh
right.
yeah.
They're usually 1-finger typing, or they're swiping. They're using their finger to swipe.
In a couple of years, it's all going to be voice control. No more typing.
I think
it'll be brain controlled with Elon Musk's monkey.
I used to call that Columbus typing, where you
already had the injection.
Land on it, and file another out and then land on it, and file another out and then land on it. Columbus typing.
What's the one day saying up here? Canada taught the world to type with their thumbs.
Nice.
Correct.
Cell phones on the Blackberries.
Thank you, Rim.
Doug, is that your robot on the floor?
Yes, I'm champing at the bit to demo, but I'm waiting.
It's your turn, baby. Take it away.
So, let me interrupt. So how are you? Do you actually have 2 different sessions logged in? Is that how it?
Yes.
Okay.
I was testing my iPhone working with just cellular, and that's over cellular, not the Wi-Fi.
So that's the picture of the robot is the cellular?
Right.
Okay.
And does anybody have the VNC viewer installed on their computer? If you open your VNC viewer, and I'm going to put, and you sign into.
You're not going to reverse hack into me, right? Like some of these
words in a day or two, but if it's you connecting to me, I'm the one taking the chances.
All right, so I got to sign out. If I'm signed into my account, I got to sign into yours, except I don't remember the password for mine, so it's going to be a problem.
Okay, so what do I do, Doug?
So if you open up the VNC viewer,
okay,
if you're signed in, then you'll have to sign out. But see in the chat where I put support@myrobotblogs.com.
Oh, no, hang on. In the chat.
Right. That's the ID and the password for the VNC account for my remote robot.
Okay. So it's telling me it sent an email to that address. Please follow
Really?
the instructions there to continue.
That's interesting.
Yeah.
Because I
So
didn't
you
get
should
that in
have
my
an
notes.
email in your inbox, apparently.
Yeah. Let me check that.
You probably need to confirm this. You know, I remember that I had to do that when I first signed into my account. It's a good
Well,
thing, right? They want to make sure.
Yeah,
You know,
I had to do that when I signed into Real VNC, but I didn't have to do that when I
So-
tested this on my other computer.
You
Looking
probably
at
have to
it now,
confirm that and allow that.
The remote computer one looks like a
new sign in.
computer on your
And I
network.
said, okay.
Doug, it won't ask me for a password. I'm just hung.
It didn't ask you for a password?
No, it's just hung.
I don't know why it would be doing that. I have to admit, what I know is what I know, and what else is what I don't know. So
That's
I
Try again.
let me share my screen for a second.
I'm in.
Okay.
It
So
says-
you're looking at my
it says,
robot control.
Oh, I'm gonna start driving.
Yeah.
It said connection refused. So
Huh.
I must be doing something wrong.
Uh-oh.
There it goes. There it goes.
So you're seeing the camera view. And
Oh, okay. I see the camera view. Okay.
Right. You're
Can I
driving.
can I rotate in place or just how
Yes.
does when I say
Only the forward, back, left, and right works right now.
I'm rotating.
Cool.
And so the robot is just my little kit
I'm gonna
robot.
time the delay that I see on my end. So I'm gonna try to time that. Hit the button and then takes like a while before the camera image updates. So
Yeah, I'm seeing delay here now too. I wonder what the deal
all
is.
right, it's like 1.2 seconds is what I measure.
Yeah.
Yeah, 1.2 seconds.
Interesting.
From
I'll
1.2
look into
seconds from me pressing the button
Right.
until I see the image changing.
Now
Yeah.
remember that's going on your phone, so it might be a little slower.
Actually, the phone is responding pretty quickly to what I hear motor-wise behind me. So what he's seeing is what he's seeing, and he's looking at the camera view. Let me share my screen here. This is what he's seeing, is the robot control module. That's interesting. When I click, I'm getting really fast response.
Cool.
Are you still connected, Chris?
I'm still there. I'm looking at the video. I'm not pressing any buttons.
Yeah, go ahead and click some movement buttons.
You know, the video that I get in the Google Meet is actually updating before. Well, there are two different streams, right? I see your pie screen,
Yeah.
which updates about at the same time that my view of the same screen updates. You know, my VNC session, but
Right.
the other login that you have going on there, where you have a camera pointed at the robot, that seems to actually be updating a little quicker.
Interesting. Yeah, this is a good test. This is the first time I've actually had somebody else try to drive it over the internet.
Yeah, I can hear the sound even much before I see my image moving.
Right. Well, good to know. So it seems to me that what you're saying is that it's drivable, but you have to be patient. Because
Well, not interactive. I think it's, for me at least, it probably would be beyond the threshold where I could drive it, right? this is at the point where you could say, all right, go 5 feet forward, and then I'll give you another command. I mean, I don't think I could, because if I start going forward, if you think about it, 1.2 seconds, right? Once I'm getting close to something, you know, by the time I release the button and the robot, I mean, I'm already 1.2 seconds behind, right? So
Right.
it's
Good to know. I'll have to try to determine how I can ameliorate that, because right now you can see these 99s. Those are supposed to be distance, but I have no distance sensor set up, and that should be telling you if you're getting close. If it was really working, when you hit a button, it moves just a little bit and stops. So it's not a continuous movement right now. The plan, not yet done, is to have go forward 5 feet or something. These are behavior buttons, like go to someplace or find something. So it can be driven this way, and it can be driven eventually by saying go to something. But I haven't hooked up anything but the forward, backwards, left, and right at this point. So I'll have to see. That's the first time I've actually had a chance to try driving it remotely over the internet, because it seems to me that I thought that I was going out to the internet through this VNC, but I may not be. It may be smart enough to know.
maybe you are, but maybe my connection is much more laggy, right? I don't know, right? Everybody's gonna potentially get a slightly different experience.
Right. I'm gonna stop with the presenting now. I think I stopped. No.
That's cool. You did stop. We're good.
Help, help.
Hey, yeah, make
I hit stop, and now it seems to be froze.
It's still working for us, Doug.
I mean, look around your house a little bit.
Yeah.
Here we go. Yeah, it may be overloading my Wi-Fi. He's trying to attack my camera. We're lucky my attack dog is.
I'm trying to find a door to get out of here.
There's no door to get out of here. I got the door closed.
Maybe some stairwell, you know, any stairs nearby?
No stairs.
If it had a gripper, you could grab something and run out, like take a beeline with.
Yeah, the direction you're going will be getting you toward the door, which is closed. You probably see my line following thing in front of you.
Yeah.
The door is coming up to your left. But
what if you drop the car keys in the floor?
Yeah. So it not quite as good as I hoped it would be. Interesting information. Maybe we'll do better next time.
Just think,
Any
Doug,
questions about?
Just think, Doug, it takes minutes to get to Mars. I mean, you're doing fine.
I know, but we want to make this so that you don't lose interest while you're at the meeting, because this is the beginning of the telepresence robot, and you remote guys are going to be doing this. Hopefully.
Yeah, but I'm on Mars. I mean, come on.
That's true. You could send your rover over once you have it built, and we'll put a robot on it.
It's like 440 milliseconds just to get there, you know?
Yeah.
The problem is that if it's too easy to control, we'll lose interest in the meeting and just start wandering around the building.
Just playing around with it, right?
Yeah. So how good can you get on the line since you have the line down there?
I got a little ways on the lines, and then I kind of lost interest because I was trying to get some other things done. My problem with my line sensors is that the line would get between the sensors, and therefore I didn't know where the line was anymore. And I had a lot of trouble getting back to it all the time. I tried putting my sensors together. This robot actually has my new arrangement for the sensors on it. And pick this up. I don't know. That's my new sensor arrangement, but I haven't tried it since I built it. And I'm going to cancel this version now to if I can. Hang up. That got rid of that one. Maybe that'll help my response a little better. But
it's looking good. Very good.
Yeah, basically, like Murray, there's only time for so many things, and line following is not one of my things right now. I've considered building an outdoor robot if I have time before August, using that rocker bogey stuff that's not the Mars rover, but the simplified version. But I don't know if I'll have time.
So yeah, speaking of that, I've surfed the web a little more. I found this, which might actually Murray might find interesting. So let me click on that. So there's another one with radar out there.
And it's got the rocker and then the other.
Yeah, they have a little different, but yeah, in a sense.
Same wheels.
So yeah, that looks interesting.
But as you can see, they again are hanging the wheels off the end of the motors, and so if you took it outdoors and ran it in the rocks, it would just bang those motors right into the rocks.
Yeah. My plan, if I implement it, will probably be to use some kind of belt-driven thing and have the motors way up high.
So, speaking of that,
ouch.
Ow. Yeah. Like I said, there's dozens and dozens of, I mean, anybody with money and a brain is going to make a Mars rover, you know?
So yeah, that's sort of interesting, but a little different layout than the normal layout.
Well, there is actually even, I mean, JPL has even published a website with plans using the Servo City stuff on how you can build a Mars rover. So, you know, it's all out there. It's more, as in any project that's as complicated as that, there's a lot of compromises. And if you really just want to have a Mars rover that can steer and drive around on flat surfaces and maybe over some terrain that you've created as barriers, then any of these are probably fine. But I'm more of a purist, and I'm trying to actually do the right thing in terms of the way the Mars rover was designed, or all the rovers were designed with, you know, and in fact, I've been collecting images off the internet of a lot of, there's a contest in Europe every year where they have, you know, countries actually throwing whole teams of people together to build Mars rovers, or not Mars rovers, but rovers. And they're all outdoors, and they take them out on courses in sand and stuff like that. And these rovers, clearly, they're often built by universities. They have, you know, $10,000, $15,000, $20,000 robots or more. And a lot of the parts are CNC machined, and the wheels are often custom. And if you go and search on Google Images for these, you can find some beautiful, I mean, truly beautiful hardware robots out there, where the compromises are, I don't even know what the compromises. Some of them must cost, you know, $50,000 for some of these robots. But for someone who wants to spend like $3,000 and living in a country where shipping is expensive and parts are not so available here, like if I was living in the US or Canada or Europe, it'd be easy to build some of this stuff. But I'm effectively looking at doubling the cost of my robot if I buy a lot of the parts from the US. So I have to manufacture, and to manufacture my own wheels, like I said, I'm trying to experiment, but I'm going to probably have to make my own wheels.
It's even tougher in Canada, Murray. I order parts and they don't show up.
Even though the shipper says they're on the way.
Yeah, so those parts I ordered, the flight still hasn't landed. It left March 4th. So the flight still hasn't landed.
There's a TV show about that where the plane just disappears and comes in somewhere else.
Yeah. Apparently nobody reported a plane crash, but I did open a dispute to see if I can get some money back.
Oh, man. Maybe it's parked on that one ship in the Suez Canal.
Oh.
I'll never get out of there. Okay. Hey, I have, is it time to move next? I have two things to share this time. The first is I stumbled on ESP32 cam. Has anyone heard of this before?
Yeah.
I think I did.
Somebody showed one. Someone has one, right? Other than you, Carl. I think someone else.
I haven't I haven't bought one, so you have, because I was just fascinated because here they have, I mean, 9 and $10 a piece, or a 2-pack for $19.
Yep.
Mm-hmm.
And there's this one site that has quite a lot of examples on what you can do with it.
Yeah.
And there's even
Random your tutorials is good.
There's even some people that have it's a subset of OpenCV, but it's looks like it's meant to run in a browser. So so you can
Yep.
run OpenCV, some slice of OpenCV on these little $10 things.
Yep.
So this one shows how to do a color detection tracker and have a web server with the camera with OpenCV, $10 board and camera.
Yep.
So anyhow, I just stumbled on that today, and that was a little diversion. The real thing I wanted to show is progress. So I'll put a link into the chat for this. And this is the kind of public announcement of Hover Sim with Asteroids mode. Yay! So so here I'll just play this, and I put the link to the YouTube in the chat. So here we go. Basically, I got it running the other day. This is not quite its first run, but not very many runs behind it. Basically, Asteroids mode turns and hold rotation. It's only got forward thrusters, no sideways thrusters, and it models like 0 friction. And the ring lights, white's compass north, blue and red is like where the hover sim is looking forward. And the green light shows you what current direction of momentum. Are you hearing the recorded audio?
No.
Okay. So basically, I got it started to move forward, and then I rotated it. I'm going to, just a second. So basically, with only forward thrusters, you have to rotate it in the way you want to go, and then give it enough thrust to overcome the momentum it had before. So right now the green, so if you can remember driving the little spaceship around in Asteroids, the game from the 80s, or if you can imagine a hovercraft, if all you can do is turn it on a dime or give it forward thrust, the way with no friction modeled at the moment, once you set it going in a direction, it'll keep going that direction until it hits something or you give it thrust in another direction. And then when it's going slow, I found it was hard to see exactly which way it was aimed. So that's why I added the green and yellow lights to tell which way is it actually moving at the moment.
That's
And
cool.
Carl,
Where are the massive boulders?
The what? Yeah. So now we need a bunch of little baby robots that I can shoot and have break apart.
Oh, that's right.
Asteroid robots.
Hey, Carl, is there any odometry on this thing at all?
No. Right now it is 4 PID loops, 1 velocity loop for each motor, and then it's using the BNO 055 for a heading reference, and that's all that's required for this, and a bunch of mind warping math for the trig. But
yeah, that's really cool, man. That's really cool.
it's a little tough to stop it. I didn't do it so well in this video. I've done it in other things and other times.
Well, I was thinking about that, Carl, when I saw it in the video. Why couldn't you have a button to push it and not just, you can cheat by just stopping the motors, but you don't want to.
No, that's what it did at the end. That's cheating.
No, that's not where I was going with it. You could say button, you can have a button that says, I want you to stop. Not tell it to stop. I want you to stop. So it knows what direction it's heading. It knows what speed it's at. Have it calculate the thrust vector for you and have it do it. Not just off the motors, but stop it the way you would have done it manually, but have a little automatic thing going because it knows stuff about itself, right?
Well, there's 2 ways, right? The one is if it had a position reference, and it doesn't have an XY position reference. It's only got rotation reference by the magnetic compass. So
according to what he's saying, though, that's all you need is a behavior that knows how to spin and thrust in the opposite direction.
Yeah, but then you need to know whether you're moving or not. And right now, because this is like a hardware simulator, I mean, I only track the wheel motion because it's simulating.
Yeah, it doesn't know it's thrust.
It doesn't know it's thrust. So
got it. Yeah.
But what I could do is, and this is just something I haven't done for asteroids mode. There, I stopped it manually. Is I could add friction in. Then it's a little more like a hovercraft because they do have a little bit of drag. So I could make it so that it keeps moving, but if you stop the thrust, then like, let's say space has a viscous resistance to it, so space would slow down eventually, and eventually bring itself to a stop. But I don't have that modeled that way at the moment.
What, you haven't modeled up dark matter? Come on, man.
Yeah, that and hyperspace. I got to get the hyperspace jump going in here.
Well, one thing you can do, Carl and I've been a little back and forth in email, and one of the things that I've announced is that Pimoroni is going to at some point relatively soon release a update to their optical flow sensor, which is now going to be called an optical tracking sensor. Maybe it's based on another PixArt sensor that is not from a drone, but is actually designed for ground-based robots, and is designed for a robot to floor distance of 15 to 35 millimeters. So it'll fit on the bottom of this robot. And as soon as one of these is available, because I've got, my little hover robot at some point, but if I mounted one of those on the very bottom of this plate, it would be at a suitable distance to be able to view the ground. And these new PixArt sensors are designed like for the surface that's on, like on concrete. It can actually read concrete and things like that. So at that point, Carl, you could then go ahead and have a stop where you just have the optical flow sensor noting how fast and just slow it down until it's 0.
Oh yeah. Oh, that's absolutely, yeah. So optical flow, one way or the other, that's in my that's one of my next branches.
Yep.
Another one is to work on the calibration of various things, because it's kind of rough in spots here, and there's still some math errors here and there. But
I was gonna say, it sounds like a lot of math going on here behind the scenes. I mean, that would make my head hurt for sure.
It made my head hurt to get it this far, but I'm pleased with it, because once I can clean it up, because another way to go is to then, especially if it has other sensors, whether it's vision or sonar or something. I mean, you could imagine doing some of our standard automated routines, but have it with this kind of a platform, right? So, and that's kind of the whole idea. For one, because I thought it'd be cool, and for another, then I thought it'd be easier to get this going than a hovercraft in a way, and more versatile.
Carl, the one thing that I've noted about this whole concept of one of these robots, because I've obviously kind of in line to maybe build one of these myself. I mean, I've started building one, is that on the other robots I've worked on, and on David's robots, most people's robots, the front of the robot is where you put all the sensors. And on a robot like this, there really is no front, because you're moving in any, 360 degrees might be the front. And so it's almost like you have to have, like some of those students of Kareem's, having a rotating sensor thing that as the robot is turning, you would determine what direction the robot is turning and have the whole sensor array rotate around in that direction or something like that. Because frankly,
then there's the other way, right? Which is kind of why I started off by showing the ESP cam, because at $10 a sensor, I could just do what Elon Musk does on the Teslas and have a camera for every face, right? I mean, why not? If every camera is smart enough to run OpenCV, and if we have the I2C Python thing figured out where you can have a smart central node slaving all these remote sensors, then why not?
Well, the biggest, I mean, let's say for let's say you had a camera that could see 120 degrees, you need 3 cameras to cover the territory. Even given that, though, you're talking about cameras as sensors. And as David and others have talked about, cameras as sensors works, except that cameras as sensors don't really work. They can't see the point of a rocking chair coming at you very well, or discern what that thing is. They don't see string, and they don't see things that might actually be barriers to the robot.
So that, and a whole bunch of sonar. I mean, it'd just be a giant sensor.
Yeah, I mean, the one thing that David does outdoors on his JBot is he actually uses, I think, the IMU to determine whether the robot's run into something. And so if you're going sideways and all of a sudden the IMU goes, and you've got a G level trigger, you could say, okay, we've run into something, and then, react to that. But it's going to be the IMU that does that, not a camera.
Yep.
In industry, the worst thing we have with cameras is lighting. As lighting changes, your control scheme goes for a crap. So you have to control your lighting.
Has anybody seen that one demo of that guy that's built? I can't remember the name of it. I just saw it a couple days ago. He's got a robot that unpacks boxes out of trucks. And oh, David, you're muted.
I posted a link to that this afternoon.
Oh, you did. Oh, that's right. And in the tests for that, they showed in the test they were using rock and roll concert smoke machines to pour smoke into the back of the truck so the robot couldn't see very well. And I thought that was kind of cool because even with all the smoke in the back, it was actually still pulling boxes out of the truck.
What I was struck by, and the reason I posted that, was because of their sort of philosophical approach, which was that they're not trying to make it autonomous. They assume that there's a human standing there, and that when it drops a box or there's some sort of odd edge case, the human will step in and take care of it. And that seems eminently reasonable to me, because it turns out in robotics, as you guys all know, that the edge cases overwhelm the rest of the bell curve. The edge cases are everything, you know.
Yeah. Well, they said, like, you know, when the robot picks up a box and the bottom of the box falls open and the parts go all over, or picking up a tire, there's so many things that end up in a shipment that just don't fit that standard box model.
This is like when your self-driving car arrives at an intersection and the light is out and there's a policeman directing traffic.
Yeah.
It's not our fault because you did not purchase the Detect Policeman Directing Traffic software package.
And of course, we just learned
the Tesla yesterday found out the hard way that Tesla's not good at self-driving.
Well,
I mean, those guys that got on the
because they
accident.
didn't get the FLT module.
You mean the two guys that got in the accident last week, you mean?
Yeah. Got fried, hit a tree.
Yeah. Well,
Dave,
apparently
what's
neither
the
one
FLT module?
Faster than light?
Well, that was one of the reports was saying that they didn't have the module that would handle that.
It's their fault.
Yeah, so the Wall Street Journal was saying that they were in full self-driving mode, and Elon Musk came out hard saying they didn't even purchase that option, so they couldn't have been in that mode.
Maybe they didn't know.
Yeah.
Yeah, right.
This is self-driving. Let's get in the back seat.
Do they have a full self-driving mode?
Well, there wasn't anybody at the wheel. There was one guy in the back seat and one guy in the passenger seat, so no one was actually at the wheel when the accident happened.
I figure that this one, just given the severity of it, it's going to have a full NTSB after action review, and that's going to be fascinating to see what actually comes out and how much of the early news was accurate.
Well, even if you think about it, even if the guy was in the driver's seat and not in the passenger seat, if, for example, the car had alerted him that there was a tree or something was wrong, would he been able to react fast enough to take over automated control and drive the car?
You know,
he didn't have his hands on the wheel. It would have been, less than a second, and it would have been an accident.
MIT did a bunch of tests on that, and basically what it boils down to is that if you're suddenly put in charge, first of all, you tend to oversteer because you haven't been following along. It's, when you first get in the car, you get a feel for how much you have to turn that wheel. And, but mostly, in order to make those split-second decisions, you have to have situational awareness. You have to know where everything is around you and how fast they're moving. Should I turn? Should I brake? What's the right response? And there's no way to do that without maintaining situational awareness. So that's going to be a tough nut to crack. If you say, well, the car is going to drive it all the time except when it can't, and then it'll turn it over to you, that means you really have to be paying attention the whole time.
Lots of luck.
I mean, if you want to sit there and you're expected to commute, so every day you get in your car and you commute to work, and you're commuting on this particular road where there happens to be a tree, and you drive by that every day, and you're reading your ebook or talking to somebody, or you're not paying attention, because that's the whole point of having a driverless car is you don't have to pay attention. You can actually read your book or talk or relax. And then all of a sudden, the car says, we're screwed in 1.3 seconds.
You take it.
Yeah, you take it.
You take it. Yeah.
That premise is in the
Those
current
Smothers Brothers, Tommy used to say, "Take it," and then we would say, "No." Take it.
in the current mode though, the premise is faulty because the current system is it's not, although it can do that in many circumstances and it does remarkably well, it's no way designed, intended, or recommended for you to remove yourself from situational awareness. I mean, so I can tell you, I mean, for people that drive these to work every day, the benefit is that like there's this road, Dallas North Tollway, okay, 3 or 4 lanes wide, lots of traffic, heavy every day in rush hour, idiots zooming in and out, changing lanes in front of you. And the thing is that these Teslas they have a situational awareness that you as a human can never really have, because they've got cameras on all angles, microwaves on all angles, and sonar on all angles, and the thing's watching it every millisecond, right? So it'll come up and beep you and alert you, even if it's driving. It'll let you know when people start to get in your void spots, and you can put it in the I think they call it platooning mode, where I mean you're in rush hour traffic like that. It's stop and go, right? Because that's just what traffic does. And in that kind of mode, you can put it in a mode where it's just like cruise control for steering, or where it's, I mean, for speed only, or where it's cruise control for speed plus steering. But either way, once you put it in that mode, as the mass of cars around you speeds up and slows down, it'll speed up and slow down. And then you can dial in the follow distance that you want. So you can say maintain 3 cars ahead. And it's really, I mean, from people that have used it, in like my brother.
But then there'll be 3 cars that hop in front of you.
Well, so you dial it into 2, but when they do that, the car, I mean, it adjusts. So, and the people who have driven this to work like that, I mean, they will tell you that, yeah, you how do my brother-in-law describe it? It's like courting. I mean, you don't just hand over all of your trust immediately, and you maybe never hand over all of your trust, but as a gradual thing, you learn, you know, what can you trust it in and then how not to. But you never really take, if you want to live, you never really take your eyes off the surroundings and your hands off the wheel.
The problem, though, Carl, is that that's from the perspective of people owning and driving the car. But from the perspective of someone who happens to be walking on the sidewalk or crossing the street, the innocent pedestrians who have nothing to do with any of this, maybe don't even know what a self-driving car is or don't even want self-driving cars. They should paint all these cars like bright pink with dots or something like that, so that when I see one coming at me, I'll know to get out of the way. Because as a pedestrian or a bicyclist or whatever, I don't want to be around these cars.
I'd drive that car, man. Give me a pink with black polka dots. I'd be all up in there.
I just don't like the stealth mode. The fact that these cars can be driving around, and if one drives by you, you don't know it's self-driving and that it perhaps is more of a threat.
So you're saying it would be a little better if all Tesla drivers were forced to dress up like crash test dummies.
Dude, you got something, Carl. You got something there, man.
Just like the Kraftwerk, right? The Kraftwerk song of crash test dummy. Okay.
There's also
the other is that they don't make any noise. They sneak up on you.
And Carl, I'm sure you've thought of these, but even if the rate of accidents is small, even if it's much less than careless human drivers normally do every day, there's a complex legal question that has to do with liability.
Oh,
and
yeah.
I don't think that those questions have been really resolved.
No.
So if I am looking down and I'm reading my email and I hit a child crossing the street, you know, I can go in front of a jury and tell my tale and try to get some mercy, which may or may not be deserved. But if a machine did that, it's going to be a totally different calculus. And so it's not just a matter of numbers of how many wrecks you have per million miles or whatever. There's a whole societal and legal aspect here that I don't think has really been resolved.
Oh, it's going to be case law, right? I mean, it's going to be cases like the one yesterday in Musk. Even before that Austin wreck the other day, I was reading some things where apparently there's an extra camera that's in the rearview mirror that's facing the cabin, and Tesla hasn't used it very much, but it's actually, if I understood it, one of its main uses is for driver attentiveness and
Spy
probably,
cam.
you know, it's part of the black box, right? Because it can now help protect Tesla to say, oh, it's the driver's fault. They removed themselves from the driver's seat. That's not our fault. But there's that, and then there's the other part of it too, right? I mean, when you get this 1,000-pound battery that's made up of like 3,000 to 4,000 18650s, right? 3,000 to 4,000 18650s, and it catches on fire like it did the other day. It took them 30,000 gallons of water. They didn't know how to put it out.
Yeah.
And from what I understood, they couldn't put it out. I mean, you can't put out lithium with water. You take some other chemicals, but
Yeah, they couldn't put it out. It just had to burn itself out.
yeah.
Are we talking the car that when it hit the tree that did that?
Yeah.
Or...
Yeah.
Look at the photos. I mean, it showed up in some UK web news page even. I mean, there's like the stanchions for the doorposts and the wheels, and then there's this molten mass of what used to be below it. I mean, there's nothing left of the car.
Well, there's one real huge benefit to this. If you think about the sort of the Burt Reynolds movies in the 70s where they'd have car crashes and the car would hit something and then it would explode. And you always kind of go, cars don't really blow up when they hit things, but if they really do now, then wow, that really makes movies a lot more exciting.
Oh yeah. Yeah, that
Murray,
was real.
I worked with some industrial blasters for a while. And one of the guys that I met had done a whole lot of Hollywood work. And so I asked him how they did those. And he told me, basically what they do is they take those plastic gallons of gasoline and they wrap them with det cord. And then they set those, the explosives underneath those. They set that in the car. And then when there's a millisecond delays, so they set off the millisecond delay, it blows up the det cord, that vaporizes all that gasoline. And with all that gasoline vapor in the air, then they set off the blast. And that's where you get those huge, in the real blasting community, if you set off a blast that had a big fire plume like that, the EPA would come and get you.
Yeah, if you go look through Mythbusters, they did a whole Mythbuster show on this. They ran dozens of cars off of cliffs with various levels of gas in the gas tank. And then they eventually, to get the effect they wanted, they did exactly what Mr. Anderson just said, loaded that stuff up and just blew the hell out of it. That was the only way they could get an explosion.
This is all now unnecessary with these lithium battery cars. I mean, they'll really properly blow up now. I mean, that's cool.
That's interesting. I'm working on a project right now with 7.6 megawatt hours of lithium ion batteries.
What did you say? Megawatt hours?
Megawatt hours.
Capital M.
Drop it down.
3.6 megawatts for 2 hours.
How physically large is that, Pat?
It is 3 C-can containers, 23 feet long by 8 by 8, whatever a C-can container is.
Good God.
So it's 3 of those, and then a transformer from 600 volts to 12.47 kV.
This is to run one Raspberry Pi.
We don't need to.
This is for my new robot. Yes.
We don't need to lose any more robot builders. You be careful.
No, this is to in Canada, in Ontario, we deal with something called global adjustment. So because of all the solar and wind power that is very expensive, we calculate 5 peaks per year from the hydro company. And if we can drop, for every megawatt we drop, presently it's about $450,000 off of our hydro bill. So if I can drop about 3.2, 3.3 megawatts and hit all those 5 peaks, that's a lot of money coming back.
Interesting.
So basically it's a paralleled online with the hydro company. And when we get the notice, the peak should start, let's say at 5 p.m., 5 to 7-ish is the peak. We start dumping energy. So we'll dump that whole 77.6 megawatts for those megawatt hours, basically. And so it's something I'm looking at. I'm presently looking at a 10-year contract with a $0 investment. But as you say, fire.
I mean,
fire.
You can imagine 7.6 megawatt hours puts off an awful lot of heat when you're discharging, 11 650 batteries.
And you have, if I
When you do
remember
that
right, you have
diffuse
trees
process.
in Canada, don't you? Trees burn, don't they?
Yeah, trees burn. And this is a sawmill.
Sweet.
Carl, if I could be so bold, I had a question I'd like to ask Chris. Chris, did you actually get your little remote sensor working?
Not yet. I don't know if you caught my comment earlier that I made to Murray, because he found out that MicroPython on his hardware didn't support I2C slave. I ran into the same issue because I wanted to use this QtPy, running just Python code. So I did just get it working in Arduino mode, meaning just using the regular Arduino framework running on this Cortex M0, and then using standard Arduino APIs to make it into an I2C slave. I mean, just pretty standard stuff. And now I'm at a point where I can, wire it up to my, QTR8 array. That'll be the next step. I haven't gotten that far because, I was trying to figure out the I2C stuff. I mean, along the way, the thought occurred to me, in principle, there'd be cheaper ways to do this, right? I mean, if I had an 8-channel I2C A to D converter, I could do it. I couldn't find any boards that small that give me 8 channels of A to D. I could probably take an AT Tiny Micro, just a micro, without even putting it on a board, and try to bolt it to this. But all of that would take me more time. So I'm just going to take this $6 QtPy, maybe it costs me $3 more than it has to, right? And bolt it onto this, and then I move on to other things.
So you have no more of those Atmel, what were they, 2313s?
I do have a drawer full of those, or a little parts drawer full of those. But, honestly, nowadays, I don't even know how I would program these anymore, right? I mean,
well, that's the problem I've run into. I actually used one of those as a data converter on one of my robots, but I don't think I could pull out what's necessary to reprogram it if I needed to.
Yeah.
So when you held that thing up, so all those little wires will connect to the device, and there will only be 3 wires or 4 wires coming away from the finished sensor.
Yeah, and I'm gonna have to desolder these existing long wires. It was just, that's what's the bulky part that needs to go. So I'm just gonna coming out of this assembly would be power ground, I2C data, and I2C clock.
Maybe Murray had something there with a single language robot.
Well, and now again, it's, in my opinion, it's not gonna buy me any extra. If I could do this in Python, I would have done it more as because I want to learn Python, but at the end of the day, I want to get the job done. So I'm gonna do it, using Platform IO IDE and using the Arduino APIs. And there are plenty of examples, and so it's pretty straightforward. It worked right away. So I just, again, I have to physically get it all wired up, and a lot of wiring things I had to do. I mean, it's again, wiring is my current. Luckily, long time ago, I bought an assortment of Raspberry Pi camera ribbon cables, like 4 inches, 6 inches, 8 inches, 12 inches, and I had to go to a longer one because, again, previously it was coming out in the front, and because this is the front, so this is where the camera would be, just somewhere here. So previously the ribbon cable was coming up and doing a twisty thing, and so luckily I had a longer ribbon cable, so I'm going to come out the back, come back around this way, and then, go into the camera like this way. So, number of wiring cleanup steps that I have to still complete. I didn't put much work into it this week.
Is that the cable? Is that one of those metal plastic things? A parallel cable?
Yeah, it is. It is kind of
flat cable.
It is one of those flat cables, which with very thin. You can barely see the traces inside of it, and then it's got the pins exposed here on one side. Yeah, that's the standard cable for the Raspberry Pi cameras, and yeah, they come. And luckily, they come in all kinds of lengths because you kind of need it sometimes.
I think you can get them up to 1 meter long.
Yeah, I haven't found anything where it comes in a round format because, again, this flat cable, again, if you do have to sort of twist it a little bit and go around a corner a little bit with that flat cable, that gets a little tricky, doing corners. I haven't seen a round wiring harness that goes with that.
No, I've got I think this is 200 mil, I think. And this is the one I have my Raspberry Pi on the back of my robot and the camera mounted on the front. This is my KRO-1 robot. And so this is the longest one I could find from Adafruit. And you can fold these things, but you wouldn't want to do it too many times.
Yeah.
So the folds that are in this are the folds that were necessary to get out of the Raspberry Pi, across the top of the robot, and then fold down towards where it mounts.
Yeah. I found myself adding some tape. This is the old one, the shorter one. I found myself adding some tape because it was getting some kinks. Again, it was getting a little congested there. So I added some tape because I felt like this flat cable isn't gonna make it otherwise. So, but now with the rerouting of it, I think I'll be better off. But so while I'm talking, since we're talking lithium batteries, so Carl will know what this is. Well, everybody knows, but Carl will know that this was my prize, from the line following competition. And then so I finally started putting it to good use. I mean, obviously you can charge nickel metal hydride batteries, which I've been using all this time, but this is really meant for lipos, which, it's really the first time that I officially own lipos now, not counting the ones that come with my drone. And the reason I own lipos now is because I bought myself one of these. This is a 1/10 scale remote controlled car, nothing super fancy, not a high-end thing, just like $100 range. And really, I bought it more for actually using it as a remote control car for my son to use it and me and my son using it. But, it got me thinking, it could serve as a platform, for an outdoor robot.
Yeah.
I don't think I'm gonna even try, competing at the competition. I've just never done anything outdoor. But, it has me thinking, once I get tired of just driving this thing around, which, is a lot of fun at 25 miles an hour. It's probably a decent, platform. And if it breaks, it breaks.
Donkey car.
Yeah, I mean, there's that, and there's Ardu Rover, right? They turned the Ardu Pilot software into something that you could use on a wheeled rover platform. So I know there's stuff out there. I wouldn't have to, invent the wheels. Just have to integrate everything. So, but this is, of course not. These things don't have a lot of torque. They have a lot of speed. It can go slow, right? I mean, it has a standard speed controller thing and proportional control. So it can go slow, but it has no torque when you go slow, right? So that's the downside. And I don't know how I would measure the speed, right? It's going to be a pain to even outfit this with encoders. So, but maybe I'll bolt some sensors onto it just to see what it looks like, collecting some GPS data, IMU data. I don't know, but yeah, maybe for now it's just a remote control car and LiPo batteries. I bolted the bigger one onto it and the one that comes with it. And the one that comes with it, again, has me thinking this is the right size. It would actually fit potentially into my Romy platform, which right now
Mhm.
runs off of 6 AA nickel metal hydrides. So unfortunately, the Romy chassis is just very well optimized, for containing those AA batteries in the bottom. So I'd have to butcher it pretty bad. I mean, there's sort of space down here, right? But it's not, to get this thing in there, or ideally two of them in parallel. But I'd have to do quite a bit of butchering of the platform. So I'm not sure if I want to do that. And so far, those nickel metal hydride ones, they have served me well. It's not a, it's not a showstopper. But that's again started playing with lipos, and hopefully don't set anything on fire. So been charging mostly outside.
Are you saying you're connecting your lipos in parallel?
No, I'm saying if I were to use it on the Romy, the only thing I can fit from a form factor point of view and from a thickness point of view, if I wanted it underneath, it'd have to be this style. This is a 2S and 16 milliamp hours, 1600 milliamp hours at 2S is going to be less than what I get out of my nickel metal hydride. So this isn't buying me much, right? I need about double the capacity to really have a true benefit over what I have right now.
What that really buys you, Chris, as you probably know, is you can get a whole lot more current out of those. So
Yeah.
for your hot rod radio controlled car, it makes a lot of sense.
Exactly.
For a robot, that you're not going to ever drag that kind of ampere out of it.
I hope not.
I don't think it matters. Yeah.
I actually have a question for the group that is related to all this, because it came up last week. I just remembered is that, as some of you know, I'm using these 18-volt batteries with this clip on the top that comes off. This is the Makita Power Tool battery, and I've also got the 12-volt version. And for this Mars rover, I'm going to have 3 electrical systems, basically 3 sets of batteries. Do you guys know if there's any issue in running these things in parallel? Could I plug 2 of these things together in parallel? Is there any issue with that? I have no idea.
Well, again, and I just only started using lipos, but from what I know is right, and that's why you have balance charges. If you put these things in parallel, the moment one drains faster than the other, you're going to have this one charging the other one, right? If there's an imbalance in the voltage, it's not as much an issue, I think, when they're in series. Even then you have to be careful, right? Because when they're in series and one of the 2 cells is already dropped below the 3 volts or 3 point something volts where you want to stop, maybe the other cell is still higher. So your total voltage looks like, oh, I'm still good. I can still go. Meanwhile, one cell has already dropped below the safe cutoff, right? And you're starting to damage the cell. So now when you put 2 of these, when you have parallel stuff going on, I think it's even more important, right? Because now you got one cell or one 2S charging the other. And so I think it gets pretty nasty. I mean, you have, it's hard to keep all these cells healthy, I think, over the long run. That's my understanding, at least. That's the problem. And that's why you gotta, and I don't know how they charge these power tool battery packs, but that's why you have this balance connector, right? Where that's what they use to check the voltage of each cell and kind of keep it in balance so that you don't run into these kinds of issues.
You want to make sure the cells have similar capacity. Well, you want them to have the same capacity ideally. And even if they have the same capacity, if one cell is worn out, then it actually doesn't, and you still have an issue.
Yeah.
What the smart chargers actually do is that connector, they discharge cells that are too high. That's the way they balance it. So you're not actually charging through that little connector, you're discharging through it. The other question, of course, is how you're going to charge all those things. My experience with lipos started with helicopters, and I burned up a couple. Now we do charge, we pull 110 amps out of those. They get beat on real hard, but it's made me gun shy. And so my general tendency would be to buy it the way it's designed by the manufacturer and charge it with his charger.
Yeah. Well, and that's, and I think, and that's kind of why for the Mars rover, the way I've described it as 3 separate electrical systems, is the idea that depending on how big the robot ends up, I'll either use 3 of these, because this little battery is a 2 amp hour, but they make a 4, and it's a 12-volt battery. And so the idea scale-wise is that these are big and heavy. So I'm at this point going to probably, for the Mars rover, have 3 of the 4 amp hour 12-volt batteries as 3 separate battery systems for the front of the robot, back of the robot, and the center of the robot, having 3 batteries, all charged on the Makita chargers safely, plugged into clips, and then the only interaction between them is using an I2C isolator, which uses, again, it's an opto isolator, so they're entirely separate, 3 separate electrical systems, and I figure that's pretty safe.
Carl, can I present for a minute?
Please do. Yeah.
I'm not sure I know how to make this work.
Lower right corner, it'll be a box with an arrow that says present now.
Select window or screen to share.
Yeah, usually a screen I find is easier if you have multi-screen system. But
okay. Can I just say?
Then you select the one you want to go, and
let's see.
Once you click on the window, then you click the share button.
It says as an allow, don't allow. Did anything happen?
There, it's coming up. You got it. You nailed it. Sizzle time.
Okay, so I had Inbot in a leather case in my car, and I had been running it all day long. It was totally discharged. I left it in the car overnight, and when I got up the next morning, this is what I found. I believe that leather case prevented my car from catching on fire. So, just a word of warning. How do I stop presenting? Stop presenting.
So you're saying it was discharged and still this happened?
Yeah, I think that there was some short in the battery. That I mean, they were good batteries, obviously, and it looked like that there never was any flame. It looks like it just got real hot and sizzled and melted. If it makes any difference, let's see.
I've seen that happen to laptops that are left in a hot car.
Yeah, who knows? I was gonna try to bring up another picture, but I'm unable to do it. So,
David, were you taking care of the cells? I mean, was it a multi-cell series configured pack, and did you make sure none of them were below the 2.9 volt or whatever?
Right. It was a pulse. If you know that company, is a pulse pack, and I charge it with a Castle charger that's specifically designed for those. And yeah, as I say, I think it was Mike Darnell of Mike's Hobby, may they rest in peace. When I told him about it and showed him the pictures, he told me a tale that they're at the shop, one of the new radio controlled cars with battery, packaged deal together, caught on fire like that, just sitting in the box on the shelf while nobody was there. And so there's at least one other data point. It's possible that I abused it or did something wrong, but I'll go to my grave swearing I didn't. I do have just some questions about presenting. Is this too off topic?
Go for it.
For a robot. Well, I've been thinking about the talk that I'm going to do in June, and how to present that. And I think what I'd like to do is have sort of a combination of things, and I've been trying to figure out the right way to do it. Watching Doug's presentation tonight with the 2 cameras suggests a way that I might look at it. And I have a couple of things here. Let me go back to present if I can.
Sure. There's a nice benefit, by the way, of doing what Doug did, because when you have a separate camera, the feed from the camera doesn't suffer like downsizing the pixels like the
Yes.
present screen does.
Yes. So are you guys getting a picture of a motor?
Yes.
We are. And
So
an echo
how-
from your two.
Now, how would I see that so that I could see what you're seeing?
In the top
you can
right
pin
corner.
yourself.
Pin myself.
Yeah.
Okay, well, let's see.
But it's on your screen, so you are seeing it, right?
Yes. Okay, I want to try to play a video. Are you seeing a
Yep.
Yep.
rebuilt after the fire?
Yep.
And he's perimeter following. Is that jerky to you? Of course, it's very smooth to me.
A little
jerky, but it's
fine.
It's fine.
Okay, and is there any sound associated with it?
No.
No.
Just my voice.
There could be a setting somewhere. I know maybe it's in some other conferencing thing. You have to explicitly say send the sound across. I don't know where that option is in here.
Would it be in the player or in the session?
I'm assuming you hear the sound, right?
No, I don't either.
Oh well, then
I don't know how audio is routed.
well, even if you hear the sound, I think what I'm saying is there might be an extra setting somewhere where you have to say, "Hey, send that sound across the connection."
I see. Okay, I'll hunt around for that. Let's see if there's anything else I wanted to do here. So that you can see that fine, and you were able to see the little graphic. Suppose I had. Hang on here a minute.
Yep, graphic.
There was a motor with a wheel.
Yeah.
Motor and wheel, and we see your whole LibreOffice draw. So we see you scrolling on the left.
So you can see this, me scrolling up and down. And what about the size of those?
The thumbnails, they're very small.
Well, no, the actual text on the screen, it says 24 volts. And
Perfect.
Plenty big.
That's big enough to see.
Plenty big.
Okay, what about? I got to shrink.
Enough for a senior.
You can make it even smaller; it'd be fine, I think.
So you can read that.
Yeah. I can read the slide 28 of 34 in the bottom info bar of your window.
Wow, I can hardly read that myself with my
No, you
glasses
got good
on.
eyes.
Big screen.
Okay.
See you, Larry.
Okay.
Oh, Larry.
All right. Well, I have some things to think about here.
Yeah. Dave, one thing that can help is if you put it in presentation mode too, and then that makes the actual slide bigger.
Now,
And
say that again.
I noticed that when I went over to the, where it says present now down on the bottom, and the next one over is 3 dots.
Yes.
If you open that up and you go to settings.
Okay.
All right. You can see that the audio is set to your microphone.
Yes.
So you might have to change that setting for it to pick up.
Ah, yes, that makes sense. Because one of the outputs it offers is the output from my computer.
Yeah.
Okay. Let's see. So if I had 2 windows, I could have one open that had me and another one open that had a video or a
Yes.
graphic or whatever.
Yeah, that's what I do every week, actually. I have 2 computers that way even, so. Yeah, so like here's the one I monitor to see what the feed is showing at the moment.
So, put that up in now rotate it 45 degrees. No, the other way, this way. No, around the Z-axis.
What? The Z-axis is up and down, so it's. Oh, yeah. Yeah.
So that it'll twist the reflection we're seeing, right?
Oh, I see. Okay, yeah. I don't know. It's a cheesy way to do things, but yeah. I'm only saying that it helps to have a spare monitor window. That's all.
And so you put in that window the thing you're displaying?
Well, okay. So here's the setup. The setup is, this is the computer. This cheesy old Sony Vaio is the one I log into that displays whoever's talking, whoever's presenting. And then it has a second monitor, which is this portable monitor, which then I use. This has the OBS software, which actually records the meeting. So that, I mean, I just bring it along so I can see who's talking, because then the main setup has this display on the left, that one is the laptop, and then that display on the right. So anyhow, you pick a screen, any screen, and it gives you a lot of options.
So
I used to try it with 3 computers, but I found with 2 computers and more screens, it's pretty flexible.
So I have on my screen, I see one that says Carl Ott that has you on it, and then I have another one that's just gray with a C.
Yeah, that's the recording one.
And is that the one you present from?
No, I present from my main laptop. So I'm sorry, I shouldn't have shown you the recording one, but what I'm saying is, if you had a second computer, you could log in as yourself again, and then you could use that to see what everybody else sees. And then you could use your main computer, like with the camera, and you could, and your presentation, and you could select windows to present. And so that's what I suggest to keep it simple, is to use a second computer as just a studio monitor for what is everybody seeing. And then that's how you can tell on your main computer, are you presenting the right thing? Because you can glance over and see it.
I got you. Okay.
Yeah, and for what it's worth, David, I did that with a Raspberry Pi without any issue.
Yeah.
Raspberry Pi 4.
Well, I'm hoping to do it with my AIM 65.
Okay.
We have every confidence in you.
Yeah, my MSI 8080.
I was going to say your TRS 80. That's the one.
Hey, don't bother those. I started with that. I didn't have to do punch cards.
Nice.
Yeah, you had to use a cassette tape.
Yep.
Kansas City Standard.
Okay. Hey, we've been going around the table. So who else? Doug, are you done? Or David, is there anyone else that has things they want to talk about this week? Harold?
I'll talk a little bit.
Excellent.
I have been floundering on my contest for Hackster, and I just pulled the plug.
Oh no!
The chip is awesome. It's got the NRF. That NRF 5340 is awesome. It has 2 processors in it. One of them for the application, which has got all the security built around it, which is awesome, and one around the networking protocol. So you can code that networking protocol to do. It's set up for Bluetooth, but whatever protocol you want to talk, you can just dump code on that to talk that protocol. So it's really flexible. It's really flexible. The other one, the other core with the application, that they coded up Doom on that. They put the original Doom on the thing, and they put a monitor on the thing, and it's running around playing Doom. So it's really flexible, really powerful. I was having trouble making the I2C stuff work. I thought it was working well, but then it turns out I can read real well, but I can't write anything. So if I can't write something to configure my heart rate monitor, my SpO2, that's just not going to give me what I want to do. And I spent several nights tracking that thing down, found an issue where they're assuming burst writes on I2C, and a lot of these little boards don't play that. And burst writes and burst reads. Literally, this Max 30102 has a 32-bit 32 location buffer that you can read the buffer to get average for one read, because it's reading it lots faster than you're actually getting the thing. And if you do a burst read on that, you'll only ever get that first byte off the buffer, even though you tell it all the other address. It doesn't accurate. So I need to not do burst writes and burst read. and they have a whole issue out there like, oh, thanks, we need to correct this and this kind of stuff. I got to the point where I'm going to have to go rewrite a whole bunch of those helper commands, and I was debugging some of the SDK stuff that they had, and knowing that I'm just going to do this for the contest and eventually not throw it away, but probably never do anything else with it. It's just not worth my effort or my time or any of that stuff or my pleasure. It got to be unfun, and I'm said, screw it. Right. So, last Monday, I got on and started a new thing, and I'm back on my robot, and I wanted to measure my current, and I got the wrong part, but I was having a hard time doing this. So I had like 2 or 3 different in-circuit measurements that's going on, and there's 2 basic types. Well, they're all the same type. It's just 2 basic interfaces. Either you can read the output as an analog output and do a check the voltage on it and do that voltage conversion to get how much current you're throwing out, or I can talk to it with I2C. And what I found was that the I2C is the way to go, because basically I'm doing a high side. These are all high side current meters, and with the I2C, the whole noise level and junk is contained on that board, and no telling what else I got going on that I might get on that analog signal I'm coming out. And besides, I didn't have anything hooked up to it, and it said I was drawing a 1/4 amp, and I'm like, there's no way. It's just not going to happen. So I went with the I2C, and I got some good numbers. It's an INA 219. There's a bunch of people that make them, and it's pretty nice, except that I want to measure more than the 3.2 amps that's coming out here, because I don't think I'm going to be pushing much more than that. But I have a feeling that with all the stuff I got going on, I may be going a little bit over that. So its bigger brother, called an INA 260, will supposedly do 15 continuous amps, and I'm like, that's crazy. But it will support more. It'll give me my flexibility that I need. So I'm going to order up a couple, 2 of those from a robot to measure both the motor side of the thing and the electronic side of the thing. So that's kind of how that's going on that stuff. The other thing is Mr. Doug D. I put a link I don't know if you've seen him. I put a link in the chat that has a guy by the name of James Burton. He does lots of crazy stuff, and he puts belts on every one of his motors that he's driving his wheels with. So I thought that might be interesting if you don't know that person. I think a lot of people at the club know exactly who I'm talking about. But if you haven't seen this person, he's a good person to get to know, and because he does some wacky things. And let's see what else. Yeah, I've attracted at least some people that were giving me information on my Twitch stream that I had no idea. And I'm like, with all those words you just spit out here, why aren't you Twitch streaming this stuff? Because you know way more than I even thought I knew about it. But that's cool. And also, I noticed a couple of you signed up for Wednesday, hanging out with us in the Hackster with Blind Via. That should be fun. He's a pretty cool guy, and that's what he does for a living, is makes custom PCB boards and stuff like that, and seems to know a lot about that stuff. So
Tomorrow night,
we're showing up. Yeah, tomorrow night. Let's see what else. I kind of lost track because I got into that contest so much on where I am on my Ross robot, but I'm going to get back on that and figure some more stuff out. I got some ideas. I got some reinvigorated kind of thing, and also because the last week, who was it? Mr. Anderson was talking about tools you should have. I threw up. I don't know. You can't hardly see it. No, you see it a little bit. That right there is the knockoff logic analyzer. And before, I could not get it to work properly because I think I was overloading my lab machine here with all kinds of stuff. And so I think that's what I'm going to do on my stream tomorrow night, is try to make this work and because it'd be a real cool tool, and especially I know with this chip on here that's on this chip is the same chip they use in the $200 or $300 ones. It just doesn't have all the surrounding buffer tech to keep it from blowing itself up if you hook it up to the wrong thing. From what I've read, and we'll see how well that works or not. And I've got a bunch of clippy things over here. I can clip on some stuff and female things to stick right on the thing, and I've got a micro USB instead of a mini USB. Who makes things with micro USB cables anymore? I know they do. But I mean, come on, man. And now you got people doing USB-C. So you can, I don't know, my bench, I have C's, I've got micros, I've got minis. A whole plethora of stuff. And I don't know. But anyway, that's kind of what I'm in the middle of doing. And I feel really bad about dumping out of that project, but it just got to be unfun, man. It just, I'm like, how about no? How about no? So anyway, that's about my rant and rave and stuff going on there, and figuring things out.
Good to see you chasing your passion again.
Yeah, and well, I will tell you, it's to the point where people were on my Twitch. There's somebody that sees me all the time goes, I can tell you're way more happier today than you were the last stream. It just comes through, right? It just comes through. So there's that.
I have enough trouble figuring out my own code. I don't want to debug somebody else's SDK. It's supposed to be working.
Well, I analyze the thing, and it's not that. I got a little bit of thing. Am I saying it's too hard because I'm old and don't want to do the shit? No, and I came to the conclusion that I'm really not. I don't think it's too hard. It's just that I do not want to spend my time cash. Everybody gets it's not money, but it's time. It's still a thing. And onto something I know I'm not interested in doing anything but trying to win a contest, which is kind of crappy. So that's the only thing you do it for, right? And I would think it would take a person, I think any one of us, by the way, on this thing, I think it would take a good 2-3 weeks of solid 8-hour a day going through this to fully utilize, because that Zephyr OS is cool, man. It's got tasks, it's got multi-level stuff going on. It's really, really a cool thing. I just wasn't going to spend that amount of currency as in my time when I figure that out. And that and the Eclipse Seger thing they give you as an IDE, I like that marginally more than I like the Arduino IDE. And I could not substitute my Visual Studio code in it to make it actually a pleasurable experience on the whole thing. So anyway, there's me and my whining and complaining and all that mess. I do have a couple more projects that I'm signing up for that is going to require me to do some SMD work, and I'm about to order me one of those fancy video microscopes. I had one ordered, but it never showed up, so I got my money back on that. And by the way, this is AliExpress. They knew it was screwed because I've a couple times I'm going like, hey man, can I get my money back? It's like $4. It hadn't shown up. Oh, it's in the mail. Trust me. You got 3 more days. And I'm like, I waited 5 or 6 days and never showed up. And they eventually gave me my money back. And on the microscope thing, as soon as it got close, I said, this never showed up. And it was like $45 with shipping and everything. And they didn't, I mean, literally, I don't know if they were watching for this or whatever, but it came way faster because, they're on the other side of the date line than we are. So, and that came pretty quick. So I'm ordering this one from Amazon. Hopefully it'll show up. And I am taking advice from the group here. I've made sure that I've got my, the microscope does not curve or anything. It's got a straight bar up. The thing goes straight up and down. So I've got lots of vertical space, and I don't have a bunch of, I forget who showed me that, but one of the folks here on the group did. And so I'm taking those advice and using it. It's got a decent screen on top of it, and I can get a USB to pop it into my my laptop here so that we can show that screen to my Twitch people and stuff. We'll figure that out. and I got me some more soldering and a bunch of flux and God knows what else I'm going to blow up before it's all said and done.
Always something.
It's always something.
Harold, I have to tell you that my experience is similar to yours. When I was first working on the bouncing robot, I spent a year working out the design for the sensor and studying Kalman filters and Wiener filters and various ways to do sensor fusion. And at the end of a year of that, what I decided was I'm spending an enormous amount of time on a project, on a problem that I don't really want to solve. I want to build a robot. And I know there are people who eat and sleep this Kalman filter crap. And I'm willing to pay them to solve that part of the problem for me so I can get on with the robot part.
Exactly. And in fact, I'm toying. This is me toying because I still want to build a damn robot that I started off to build. I still want to do that. But I'm toying with putting that aside and building one of these my Exo ones because I've got a blueprint. I've got a thing. I'm going to stand on the shoulders of those folks giants to use their stuff. And I've got a 3D printer, so I can print all. I got it. You know, it's just a matter of, you know, spending the money, buying the parts and doing the thing because they've got it. I've got a blueprint. I don't have to come up with this stuff and figuring on it. So I'm really on the cusp of switching gears and doing that.
Cool.
Because it's going to take a while to print the parts, and I can be doing other things while I'm printing parts and stuff, and that's fine, right? And to order some stuff, and I'm really, really close. And there is a clock. I wasn't really anticipating on joining in the outdoor Roborama, but I don't know. We'll see. We'll see what happens.
It's fun. You know? You could do if I do it, I'll probably just aim for the first cone because that's about all I have time for if I can do that. But
yeah, I think the thing the course is designed to let you grow.
Yeah.
I mean, you know, the least amount of effort and get a point is to simply point your robot at the first cone. And we saw a kid do this. You know, nothing but go forward, lock the steering.
Mm-hmm.
And he said it, and it just ran to the robot, and touched the cone. Okay. Now, in his case, the rules were different, and by touching the cone, he essentially won. But we've got a longer distance now. But in theory, you could aim it in the right direction, and if your robot would go straight, if you could make it go straight, all you have to do is be within 10 feet of the cone. And then, and if you stop, so let's say you have real odometry, you could get a second point. You know.
Yeah.
And so I mean, it's meant to help a person start with a simple goal and just keep building. You can get 6 points if you can stop and touch the cone. And let's say you don't have obstacle avoidance like more sophisticated robots. Well, if you score a point on a cone, you can go back to the home cone. All right.
Oh, okay.
So you could potentially go 6 points that way. Otherwise, so if you read the rules, it says you can't go back to the home cone until you've scored a point on another cone. All right.
Oh, okay. I got you.
So, I mean, to get 9, you have to go to all 3 cones, and it makes more sense to go from the challenge cone back to the home cone than going from the challenge cone back to the other cone and then down. I mean, just slow you down. You want to go back as fast as way you can. So you can, I mean, it's really incremental. I mean, you can start off super simple. And like I say, this year we're giving a mug if you get a single point.
We'll see, because that really idea of of shelving that thing and just going with that main deal there of already I have a recipe, I have a thing, I have stuff still to figure out. and it's definitely a capable robot. That's one of the reasons I brought it to the club to say, what do you think about this? And now we've got them presenting here in a couple of weeks. So I think that's a thumbs up on that robot there as far as a thing, right? So I'm taking it as that. So that occurred to me while I was talking that maybe that's what I should do. And that could be fun all over the place. And then while I'm waiting on parts to show up or whatever else is going on, I can still do other things on my Twitch stream, and you can show progress and stuff as it goes. So I'm not doing it all for the Twitch stream. I would be doing it anyway. It just if I can make it a little more entertaining where more people are showing up, because folks are starting to show up on occasion, and we're having quasi conversations, and I'm building a little bit of. It ain't much of a community, but it's a little bit of one. And I think that's cool. I think that's cool. So, yeah. I don't have kids, so I got to share it with somebody. And you folks have to be part of that, by the way. So you're not my kids, but but anyway.
It's all good. All good. All right. Good to see a happy Harold again. All right. So
yeah. There's no doubt about that.
All right. So who else? So Ray, John, Doug, you guys have anything this week?
I think Gene has something.
I can share something.
Yeah.
Yeah, let me get your opinion here.
I'm going to have to bail.
Okay.
See you, Doug.
Yeah, see you, Doug. So, are you able to see my screen?
Oh, look at that!
Oh, wow, a lot of progress.
Well, okay. Let me kind of explain my problem. I mean, my question here. So let me see. I will zoom in. So this is my major improvement. Earlier, there's some wiring connection. So earlier, what I did, well, I'll go back. Earlier, what I did is I have this bunch of wire coming directly down to the motor drive. And some connection is not good. So, I mean, it's just a little, sometimes working, sometimes don't. So what I did this round is I have all the wiring coming from the, I mean, there's motor and there's the Arduino. So source goes all the way to this board, and the destination also goes all the way to the board. So basically, this board is just a coupling location. And you can see, basically, I used it. I used it. It's working, but what I used it is there's a long pin on this side. You can see the pin here. Many pins on this side, and many pins on this side, and it's just the wire coming in. Again, it's working, but it's a little locked down. I mean, I can't really shift it because it's coupled to motor wires. It's coupled to this motor drive, and it's coupled to the top. And I thought of one thing.
So what are you trying to accomplish, though? I mean, what would you do differently?
I thought it was going to be very, very. I thought I have to wire so many different things on that prototype board, but it turns out it's just. So what I'm thinking is, if I have this type of wire, I mean this type of pin with two ends, and they are long enough, that's basically what I'm doing. Basically, I'm putting two wires in together. But I don't think there exists such a, this type of pin. Do you guys know what I mean?
Oh yeah,
they do. Yeah, those are meant to like solder on one side and have connectors on the other.
Right.
But you want one that has connector on both sides, and those are out there. They used to have them at Tanner's.
Oh, okay.
So this is the. Can you see this?
That's
the one you're showing.
That's the one I'm showing, right?
Do you see this?
Yeah.
I think that's what you're saying. That's what you want, right?
Yeah. What's the name of that?
Well, I don't know if they have a different name. You just have to look for one that has. They probably, I don't know. Maybe it's called double-sided. I don't know.
Like that.
Yeah.
Yes, that's right.
Yeah.
So I'm thinking, yeah, I might use this to. I can break apart my one board. That one board is a little difficult to use, and it's, initially I thought it's gonna be somewhere flexible. I wire things together, but now it's like dangling in the middle of the air. I can't put it up or down because it's, the wire. I'm using a 20-centimeter wire, so not long
John,
enough to
check,
move around.
check the Adafruit link I just added, because they sell this in Adafruit for exactly the purpose that you want. They call, in their own words, breakaway header is like the duct tape of electronics.
Nice. Okay. Good.
Yeah, and John, I'm using basically the DuPont headers either plugged onto the standard pins like you were looking at there that are soldered onto a board, or I do onto these double length ones, which you can connect end to end if you wanted to, or you can plug them into I can do this, a solderless breadboard. So effectively, I don't.
I see.
Yeah, so I've got,
Changing the gender. Right.
yeah, so I can use these. I can use these.
Yeah.
This is a brand new breadboard, so it's a bit stiff. But yeah, these double-ended ones come in a long, 40 pin or whatever, and you just snap off as many as you need, and you can use them to go end to end like that.
Perfect.
Or you can plug that into a solderless breadboard, or you can plug that onto the ones that are soldered onto a board. But effectively, that's what I've wired everything together with in my robot. So.
Cool. Yeah, I'm gonna make a bit better. Yeah. Now, the other thing I had the issue is I'm missing a few like these power pins. Now I plugged everything in. I can't really take it off to solder anything new on there. So it's a little awkward. So you can see on this one, I still have to use it because I need a little like 2 more power connector. Cool. So I'm gonna try that. Other than that, I get this robot now mobile on the, I can put it on the ground, moving around with the odometry working. So I'm gonna program this, give it a waypoint and let it feedback, go somewhere, automatically. So hopefully next week I got something even better. This is already, I think it's a good development already.
Looking good. Looking good.
Thanks, guys.
Yeah, impressive.
Looks good.
So yeah, thanks.
Very
great,
nice.
Great to see that link. I'm gonna definitely simplify my board. It's doing something really trivial. It doesn't really take a prototype form.
I found the link. You can get them in bulk on Amazon too. So
perfect. And the other thing, I went to this fair park and volunteer today, so it's pretty interesting.
You got your shot. Shot one.
COVID vaccine.
Yeah, I got the second shot today too. Just
good.
I mean, it's quite a distance, so I just went and volunteered. So I think most people I saw was like second dose. I don't know if they're running out of people. Yeah,
they are.
I just wonder. Yeah, what happens?
Yeah, they
when
were saying
the
that
second dose
they have the capacity to vaccinate many more people that are showing up, and they're really trying to get people to
like
utilize the
10
capacity.
a.m. Not many people. I mean, and very early in the morning and late in the afternoon, it's many people. But middle of the day, it's pretty open.
What vaccine are they using? Do you know?
It's interesting. Today it's only Pfizer. But when I see, like yesterday, there's both Pfizer and Moderna. And when Johnson was there, that fair park has 3. They have literally, they need to write on the window what type, like which dose, what type, Pfizer, Moderna, J&J, so that we can direct them to the right lane where the tent is giving the correct.
So they're letting people choose?
I don't know that part. I don't know that part.
I personally wouldn't want to get the Johnson and Johnson. I mean, if it were
okay.
me, I'm already vaccinated. But if I were not vaccinated, I don't think I'd want to go for the Johnson and Johnson. That's just my personal opinion. That's
for me, I feel if I've seen people going there saying I'm not registered, I'm just here, and they will basically do all the document there to let people give them the shot. And I think they need to. Their goal is to give as many shots as possible, not to limit anybody, because they have the vaccine, and they have the space. So
probably the Johnson line is the shortest.
Well,
you can get right up.
If I remember right, Johnson & Johnson's on hold right now, and probably will be for another couple days at minimum. I think that right now it's reviewing, and their thought is that it's going to be, they'll sort of have a restriction type thing, like, if you're a woman of bearing age, not to get it type thing. As of least yesterday, I think it was on hold for that reason.
Yeah. Well, I know that a lot of people that I've talked to that are just now becoming, eligible for vaccination. Some of the younger people, they don't like the idea of going back twice. But I encourage them to go get one of the ones that already had several million people flopping around with it in their arms. So
and the side effect right now is basically 5,000 have had what they call pass through or whatever anyway, but 5,000, and out of that 500 have died. So in other words, you see it, need to be careful, keep reasonable distance, don't assume you're Superman in other words. But and then on Carl, you mentioned about the rash thing that you got, and I saw an article on that. In fact,
I mean, it was minor.
Okay.
I lucked out.
Because it says herpes infection possible with the seemingly where was it? Somewhere, what spot? Oh, it said a spot somewhere. Israel. Signs that Israel has 6 cases. So so you get side effects.
It was minor,
but it's minor compared to the other possibility of
breathing issue.
Yeah.
Well, guys, I'm going to call it quits.
Okay, Doug, we'll see you.
Okay.
We'll see you. And unless there's anyone else, then why don't we can wrap it up? Ray, did you have anything this week?
No, I'm working on mechanical things again. I was trying to figure out how to hook up
the lawnmower,
a linear actuator, and still have manual steering if I need it. Because the thing weighs a lot, and it's very hard to push. And
so you don't want to run it into the tree, or yes.
What's that?
You don't want to run it into the tree. You want to be able to take control of it.
It's just heavy, and
right.
So I think I figured out a way. I can just remove a cotter pin and basically pull out. I'm not certain what they're called. It's like just it's got a head on it, and it's got a hole in the other end. I guess just a pin, and easily go back to manual steering.
Right.
And if something happens or whatever, but I try to put that thing in all ways. It's like there's a bar that connects the two front spindles together, and I thought, okay, I'll attach it to that under the front, but that's where the muffler points out. I don't want all that hot air and gases and smoke blowing against the thing. Then I thought, okay, I'll put it in behind the motor, in front of where the driver would normally sit. And that just didn't work out. The dimensions weren't right. I couldn't, there's no place to mount it. So we finally came up with the approach. It's actually on the side now, and it's not exposed to heat or anything. So I think it'll be good, but it's just a lot.
Ray, if your lawn mowing robot hits a tree and explodes, just make sure there's a camera crew there.
Okay, all right. I'll be sure to televise it.
And that there's nobody attached to the pushing part in the back.
Wasn't
They're
that
just or being drug along behind.
wasn't that a famous philosophical question? If a lawnmower hits a tree in the forest and explodes and there's no camera team running, does it make any sound?
That's right. It may not.
Right.
Anyway,
A question that vexed
hopefully,
mankind.
I was hoping to have a video today, but it's just crawling around on that thing and on creepers and kneeling on it, and trying to be a contortionist to get this nut and bolt that some engineer decided that no one would ever take out. But, anyway, so but maybe I'll have a video next time. That's I keep shooting for that, so it's gonna happen one of these times.
It will get there.
Yeah.
We'll call that the Godot video. It won't be here today, but it'll certainly be here tomorrow.
Yeah.
I don't catch the reference. What's the reference?
I'm sorry.
It's a play by
Samuel Beckett, Waiting for Godot.
Oh, okay.
These two characters just wait, and each day a messenger shows up and he says, well, Godot can't be here today, but he'll certainly be here tomorrow. They always believe him.
Uh-oh. Well, hopefully that's not going to happen to me. Hopefully, eventually,
You'll bring us a video, Ray. We expect the video. It'll come.
Okay.
As long
Okay,
as you don't
guys.
ship
Are
it
we done?
from China, but as
I
long as you
think,
don't ship it
we're
from
done.
China,
We're all petered out this time.
take care.
Take care.
You guys have
all.
a great week.
See you guys. Bye.
Catch you later.